Hello Year 12 chemists, welcome to TP's Chemistry Cuts. In this introductory video we review the particle model of matter and then go on to see how a chemical formula can be used to identify the type of particle in a substance.
Okay, so we're going to start 91164, two parts to it, starting off with structure and bonding, and then something completely different. You're going to look at thermochemistry. And thermochemistry introduces some basic principles. We've already had a taster of those in the chemical reactivity, and then goes on to do a little bit of calculational work. In this first part, though, the property of particles, we're going to take learning that you did in Year 9 and extend it and then apply it. Okay, so we're going to look at what we mean by particles and how they apply to matter, and then apply what we know to get better understanding. So, before we go on, it's worth 5 credits. So this one is there's a lot of content. So the other 2 externals are worth 4. This one's worth 5 because of that extra bit of content that you got. And it's externally assessed, so you're going to get an end of topic test, an end of year exam, and then the real thing. Now, as I say, what we're going to do is look at the particle model for matter and then use it to explain different properties of different types of substances. So of course what we've got to do is wind everything back to Year 9. Oh goody. We're going to go back to Year 9 and remind ourselves what we mean by the particle model of matter. So let's start off with that, okay? This is really nice, I think, because it shows that what you were doing in Year 9 wasn't just playing around. We were, in fact, laying down the really important stuff that we're going to work with later on. This is the foundation for chemistry, and it's really quite important we understand it. So what do we mean by the particle model of matter? So first of all, let's start off with what do we mean by matter? What is matter? Simple definition. What would be the easiest definition that you could think of that would define matter nicely for us? Yes. So simple word, the word we're looking for is something that has mass and maybe some volume associated with it. Okay? So what do we mean by a particle then? What do we mean by a particle? What is a particle? It's really quite important we distinguish what we mean by particle, so we or explain very carefully what we mean by particle, so we don't confuse it with other things that we're going to come across. So what is a particle in terms of matter? Keep it simple. Always keep it simple. Why don't we look at something that's an analogy for matter? A really good analogy, and I use it with all my juniors and probably some of the seniors I've taught before, is to take a brick wall. If we look at a wall, that's one object, isn't it? It's a wall. But the wall itself is made up of bricks. Those bricks are a repeating unit that we use to build the wall. And that's exactly what matter is like. We have some repeating unit, and you're using it again and again and again and again to build up whatever matter it is you've got, whether it's a solid, a liquid or a gas. But it's always a repeating unit. And that's what we're talking about when we are talking about particles. Okay, so the particle is not atoms, molecules, ions or whatever for the moment. It's just that repeating unit. So let's write that down. Now the thing that confuses people is there isn't just one type of particle. Okay? Different types of matter have different building blocks or different particles. And so we need to home in on that and have some simple way of identifying which particle we're dealing with. Okay? Because we need to know that first. The very first thing we need to know is what type of particle. And there is a very simple way. Okay? And we'll come back to that in a second. But let's take this one step further. We haven't finished our model yet. If we cool down any matter at all, it will eventually liquefy and then solidify. Why? Why do things solidify or liquefy and then solidify? Why isn't everything a gas? I think simple idea. We've got our particles. What's happening?
The bonds are getting closer.
The bonds. What do we mean by the bonds?
Of the particles.
So what are we talking about? When you talk about a bond, that's very we're keeping it simple. We're first coming across this. We've got these particles. Why are they solidifying? Yes?
Because of their attractions between the two particles.
You're almost there. Attractions are, let's put this in, attractive forces. The reason they're solidifying or liquefying is there are attractive forces pulling them together. Now, for many things at room temperature, there's so much energy around, that's overcoming all those forces. But if you remove all energy, or enough energy, then absolutely every bit of matter in the universe will solidify, because there are attractive forces acting between those particles. And that is basically our model. Okay? What we're saying is we have matter is anything with mass. It's made up of these building blocks called particles, and between particles there are attractive forces acting. Okay? And those attractive forces are what we label with this universal label of bond. But let's take it all the way back so we really understand what we're talking about with a bond. We're talking about attractive forces. So the important thing are these attractive forces, or bonds. Okay? And from this, we can make two general statements. Okay? First of all, and this is where we're going, that there are different types of particle, but the type of particle that we have depends on what types of elements we've got in that sample of matter. Okay, so that's the first thing. And then secondly, the attractive forces that act between those particles depends upon the nature of the particle. And that's what we're going to be looking at. Okay. So let's write that down. So that's basically our starting point. And throughout this topic, it's always important to remember that, because everything comes back to that model. We've got our little bricks, if you like, and our cement acting between them. And the bricks depend, the type of bricks that we're going to use depends upon which atoms we've got present, or the types of atoms we've got present. And the strength of the cement depends on the type of particle we've got. So that's our starting point. Now, let's address this first part, where the type of particle we're going to deal with depends upon the elements present. That basically is telling us that if we want to find out the type of particle, we've got a sample of matter in front of us, and we want to know what type of particle we're dealing with, there, what building block it is. Our first port of call should be something very simple. What? What will help us with this? What would help us? If it depends upon the type of element, what's that little bit of information we always deal with in chemistry that will help us to work it out? Using a formula! A chemical formula, that's what I wanted. And the chemical formula tells you what?
What's in the molecule and other elements.
Which elements we've got in there. So if we look at the formula for a substance, just look at what's in the formula, that probably will go a long way to telling us which type of particles. And in fact, that's what we do. Okay? So, let's write that. It depends upon the type of element. The first thing you should look at is the chemical formula. And yet you will forget. I'll ask you, what type of substance are we dealing with here? Later on, and you'll say, oh gosh. And you're trying to memorize other things. And all you need to do, first of all, first port of call, is look at the chemical formula for the substance. Always go to the chemical formula. So this is probably the most important part of this part of the topic that you get this right, because you always should be coming right back to the beginning and working out first of all the type of particle. Then you're going to look at the nature of the forces acting between the particles, and then we're going to look at what the consequence of those types of forces have on the properties of the substance. So it's one step at a time. So we're going to look at 4 different types of substance, each of which has a different type of particle. And the first one is one you'll have dealt with last year, and that's ionic substances. And the way you can tell the type of particle is by looking at the formula, the chemical formula. So your first port of call is always look at that chemical formula. And ionic substances are always have in their formula at least one metal and one or more non-metals. Okay, so if the formula contains a metal and a non-metal, okay, it's ionic. And the particle we're dealing with is ions. Okay? And we've gone through all this, and we will go through it very briefly after I've gone through this table. This is the one thing we've dealt with. The forces that act between ions can be simply stated as ionic bonds, or if you like fancy, electrostatic attractions. Now, the next one are metallic substances. Now, let's keep adding time. And not surprisingly, these have in their formula metals only. Now, that includes things like alloys, but as part of this course, we do not deal with alloys. Okay? We are only going to deal with pure elemental metals. So when we say the formula has got metals only, it's just one metal. Okay? And when we're dealing with metals, the particles are atoms. They're made up of the same atom all the way through, just repeatedly stacked together. Okay? And the force between particles are metallic bonds. Then we're going to look at molecular substances. And these are non-metals only. And the particle we're dealing with here are molecules. Now, a number of you will not have come across molecules before in any depth. Okay, those of you that didn't do the chemistry level 1 course, these will be new. Don't panic. A whole section of this topic is about what molecules are, how we build them up, how we draw them, what their shapes are, and so on. Okay? Now, this is where some confusion comes in. What we're looking at is forces between particles. The problem we have with molecules, and this often causes confusion, is that molecules are actually made up of atoms covalently bonded together, a small set of atoms, and they're done in a particular pattern, and every particle has exactly the same pattern of covalently bonded atoms, but it's a small number. So that's your particle. The bonding between the particles is not covalent bonding though. It's what we call intermolecular attraction. Okay. And in fact, that's more complicated than it first looks. There's actually several of them, or 3 of them in particular, and you'll deal with those in more detail next year in year 13. The final ones are extended networks. And to some degree, they have quite a lot in common with molecular substances, in that what you've got is non-metals only. And those non-metals atoms are covalently bonded to each other. Okay? But now we're not talking about a small set of atoms, we're talking about extended networks of them. So in effect, when you pick up say a crystal of one of these things, that is one particle in its own right, because it's just made up entirely of a huge 2 or 3 dimensional network of covalent bonds. Okay? And these are atoms covalently bonded together. So our repeating particle is actually an atom. It's not a molecule. Okay? It's very difficult to see the difference, but we will get there. We'll look at these in a little bit more detail later. And the forces in these substances are covalent bonds. And there's a very dramatic difference between those, as you'll see. So that's basically a summary of what we're going to do. We're going to look at each of these 4 types of substance. We're going to look at some detail, particularly at the force that acts between particles, and then we're going to link that model to each of these properties, physical properties. Okay?